Most healthcare AI teams think they've solved their HIPAA problem the moment they lock down who can log in to the assistant. They haven't. Insurance companies are pointing AI at millions of claim records. Hospitals are building assistants that search years of physician notes in seconds. Almost all of it runs on RAG, Retrieval-Augmented Generation, which searches your own documents before it writes an answer. RAG is why these tools work. It's also why protected health information ends up sitting inside a vector database the moment you turn the system on. Restricting who can log in never touches that. Developers still see the real patient record while they debug a bad answer. Testers see it while they run a new prompt. Support sees it while they work a ticket. I'll show you exactly where a patient's name leaks into a healthcare RAG pipeline, why login restrictions never reach that leak, and the architecture that lets the same pipeline run without a real name ever touching the model. Point 1. Picture the insurance company doing this today. Millions of claim records, lab reports, billing documents, physician notes, customer correspondence, all of it feeding one AI assistant. The first step is ingestion. Every document gets converted into vectors by an embedding model, so the assistant can search by meaning instead of exact keywords. That part works well. The problem is what goes in. The documents entering that pipeline still carry the original patient information, Jane Davis's name, her medical record number, her diagnosis, her social security number. If it's in the file, none of it gets protected on the way in. It gets embedded, indexed, and stored exactly as it was written. So the vector database isn't a search index anymore. It's a second copy of the patient's chart, sitting wherever your AI stack lives, searchable by anyone with access to that database. That database is the quiet problem. The loud one shows up the moment someone actually asks a question. Ask the assistant about one patient and watch how many people end up seeing her name before the answer ever reaches a doctor. Point 2. Someone types, "Show me all claims related to Jane Davis." The assistant searches the vector database, pulls the matching documents, and writes an answer. Technically, it works perfectly. But look at everyone who touched Jane Davis's real name to get there. A developer investigating why the model hallucinated last week. A tester running a new prompt through the same environment. A prompt engineer trying to improve the wording of the answer. Every one of them now has access to protected health information they never needed for their job. This isn't a rare edge case. It happens every time someone opens a ticket, tests a prompt, or debugs an answer, which for an active AI product is multiple times a day. The answer was correct. The path to it wasn't. The obvious fix is to lock the door tighter. It doesn't work the way most teams think. Restricting who can open the app doesn't touch a single person on that list. Point 3. Most healthcare teams respond to this by restricting the application. Only certain employees are allowed to use the assistant. Case closed, they think. It isn't. Access control on the finished product doesn't reach the people building it. Developers still investigate hallucinations. New prompts still get tested against real data. Retrieval quality still gets tuned by watching real answers come back. Support still opens tickets and pulls up the same records to figure out what went wrong. An AI application changes every week. Every one of those changes runs through the same protected health information, no matter who's cleared to use the app once it ships. Restricting the front door does nothing for the workshop behind it. What healthcare teams actually need is a way to build and test the assistant without ever handing the workshop a real patient. That's the exact architecture Protecto Vault runs on, and it starts with a decision that sounds too simple to work. Point 4. Protecto Vault sits in front of the pipeline before any document reaches the embedding model. It scans every file for HIPAA-regulated identifiers, patient names, medical record numbers, social security numbers, dates of birth, phone numbers, addresses. Instead of deleting what it finds, Vault replaces it with a consistent token. Jane Davis becomes patient J, 123. Medical record number 4, 5, 6, 7, 8, 9 becomes MRN, A501. Every time that same patient's name shows up in every document, it becomes that same token, not a new one. That consistency is the whole trick. The identifiers change. The relationships between patient, diagnosis, procedure, medication, and claim stay exactly as they were. The document still means the same thing. It just doesn't carry a real identity anymore. That masked version is what actually moves forward. Everything downstream, the embeddings, the storage, the search index, only ever sees the token. Point 5. Once a document is masked, it moves through the rest of ingestion exactly like before. The embedding model reads the masked text and generates vectors from it. The vector database stores those vectors, along with the masked content, not the original. Nothing about the pipeline changes. The embedding model still does its job. The database still indexes for semantic search. The only difference is what version of the document it ever sees. From this point forward, the real patient record isn't in the AI stack. Not in the embeddings, not in the index, not in anything a developer, tester, or support engineer could open and read. That raises the exact question anyone building this would ask next. If the database never learned Jane Davis's name, how does a real question about her ever find the right file? Point 6. Say a physician asks, what medications was Jane Davis prescribed after surgery? The vector database has never heard of Jane Davis. It only knows patient J123. The prompt runs through Protecto Vault before it reaches the retrieval system, the same pass every document went through during ingestion. Vault recognizes Jane Davis and swaps in the exact same token, patient J123. Now the question and the stored data are speaking the same language. Retrieval runs exactly like it would on unmasked data, because underneath the tokens, the meaning never changed. The model generates its answer from masked context only. It never processes Jane Davis's real identity at any point in the loop. So the answer that comes back is still wearing a mask. Whether Jane Davis's real name ever gets put back on it depends on exactly one thing: who's asking. Point 7. The model's answer reads, patient J123 was prescribed metformin following the procedure. Before that answer goes anywhere, Protecto checks context-based access control, or CBAC, against the person asking. If it's the physician treating that patient, or a claims investigator with a legitimate reason to see the record, Vault unmasks the token. Patient J123 becomes Jane Davis again, and the physician gets the complete answer. If it's a developer, a tester, a data scientist, or anyone without that authorization, nothing gets unmasked. They get the identical clinical answer: metformin, the procedure, the timing, just without a name attached to it. Same information. Only one of those two people ever sees who it belongs to. Run that same check at every stage, not just at the end, and something changes about what this architecture actually is. Point 8. Run that same logic across ingestion, storage, retrieval, generation, testing, and response tuning, and you get an AI assistant that never has to choose between useful and compliant. One healthcare insurance deployment built on this exact pattern now runs across more than 50 million records, with an estimated $30 million to $60 million in annual benefit from the AI work that finally got unblocked. Two more things worth knowing before you build this yourself. Naive masking tools usually kill AI accuracy, and context-based access control is becoming table stakes for any enterprise AI system touching regulated data. I'll cover both in upcoming videos. You've just seen a RAG pipeline that never trades usefulness for compliance. Next problem: context with nothing to mask, like a paragraph of legal or financial risk. That's exactly what's next. I'll put the video up on the screen for you to watch next. Visit www.protecto.ai for more information. Follow us for more content related to safeguarding your data in the age of AI.